Let's take a look at a few more examples where we simplify expressions involving rational exponents. So example 3D, use the rules of exponents to simplify each expression. Assume that all variables represent positive values. We have in example D, x raised to the 1/9 times y, all raised to the 3/2 power, divided by x to the 5/6 times y raised to the 1/2 power. Now when we're simplifying these types of expressions involving exponents, we want to recall the exponent rules that we use when we have just regular integer exponents. In this case, notice we have two factors, x and y, being raised to a single power. So let's pull up the power rule that explains what to do with this type of a situation. What we call power rule number 2, a product raised to a power, tells us that when we have two factors being multiplied, a times b, both raised to the same power, that's the same thing as raising each factor to that power. So a times b to the mth power is equivalent to a to the m times b to the m. We want to use this power rule and simplify the numerator of this fraction. That means that we are going to have that x raised to the 1/9 is raised to the 3/2 power, and y, the other factor, is also raised to the 3/2 power. So that's what power rule number 2 will help us to do. I'll keep the denominator the same and deal with that afterwards. So for now, we've simplified our expression this far. Now, what do we do when we have a power to a power? Let's simplify this numerator even farther. For that, we pull up our next power rule. Power rule number 1 tells us that when we have a power raised to a power, we multiply our powers. A to the n, all raised to the mth power, is equivalent to a raised to the m times n. So using that rule, we have x raised to the 1/9 raised to the 3/2. That's equivalent to taking x raised to the 1/9 times 3/2. When you have a power to a power, you multiply exponents. Y raised to the 3/2 is simply y raised to the 3/2. And our denominator is the same. It'll be x to the 5/6 times y to the 1/2. All right, so let's multiply this out. We have fraction multiplication. Multiply numerators, multiply denominators, but first I like to cancel. So the 3 is a factor of both 3 and 9. 3 goes into 3 one time, 3 goes into 9 3 times, so I canceled. Now I'm going to multiply straight across, and so when I do that, I get the following. X raised to the 1 times 1, which is 1, over 3 times 2, which is 6, so x raised to the 1/6, y to the 3/2, all over x to the 5/6 times y to the 1/2. Perfect. We are almost done simplifying this expression. Now the last thing is when you have like bases on top of each other, x to the 1/6 and x to the 5/6, these can be combined into a single base. Similarly, y to the 3/2 over y to the 1/2 can also be combined into a single base, y to some power. And the rule we need for that is our quotient rule for exponents. The quotient rule for exponents tells us that if we have a base raised to a power divided by the same base raised to a different power, we can combine those into a single base by subtracting the exponents. So that's what we're going to do right here. We have x raised to the 1/6 divided by x raised to the 5/6. So we're going to combine by subtracting the exponents. So this is going to give us x to the 1/6 minus 5/6. Similarly, we have y raised to a power 3/2 over y to the 1/2, and we're going to combine by subtracting the exponents. 3/2 minus 1/2. Now, the nice thing about this is that when we're subtracting, we already have like denominators. So our next few steps will be pretty simple to finish. X to the 1/6 minus 5/6 is equal to x raised to the negative 4/6 power. Y to the 3/2 minus 1/2 is y to the 2/2 power, right? Because we just subtract 3 minus 1 and get 2 on the top. And if we simplify these exponents farther, that tells us that this is x raised to the 4/6. If we simplify, is equivalent to 2/3, correct? Because 2 divides into both 4 and 6. So we have x to the negative 2/3 power. Y, well, 2 divided by 2. 2 is also a factor of 2 and 2, so that's just y to the first power, right? Or just y. So we have that this expression is simply x to the negative 2/3 power times y. Now, often, the instructions will tell us not to leave our answers with negative exponents. And if that's the case, then we need to convert this negative exponent into a positive exponent. And recall the rule for negative exponents. We take our base, and if it's in the numerator, bring it down to the denominator. So that tells us we will have y over x to the 2/3. That negative exponent comes down into the denominator and becomes positive. So our original expression simplifies down to y over x to the 2/3, which is the same thing as x to the negative 2/3 times y.